Alright, so in this video I'm going to show you how to find the inverse, I-N-V-E-R, inverse of a 2 by 2 matrix. Okay, finding the inverse of a 2 by 2 matrix. Well, let's go back to our example. We'll show you the general formula and then we'll do a specific example. Let's say we have this matrix A, which we're going to have these elements again be A, B, C, and D. Well, what we do is to find A inverse, which we denote A with a -1 in the superscript. We just put 1 over the determinant of A, so we'll write it like this, absolute value, but this stands for determinant of A. Notice it's a capital letter here, so we know we're talking about a matrix. And then what we need to do is we need to rearrange matrix A. So D and A swap places, and then we have the opposite signs on C and B. And then you multiply that. So let me show you a more specific example. Let's let A equal, say, 2, -3, 6, and -7. Alright, so what we want to do first is we want to find the determinant of A. And remember what we do is we say 2 times -7, so 2 times -7 minus 6 times -3. Okay, so that's -14 minus -18. Remember, if we have a negative and a negative, that's going to make a positive, so this is really -14 plus 18. So our determinant here is 4. Okay. Determinant of A is going to be 4. So what we do is we are going to write it A inverse equals 1 over 4. And then remember we need to rearrange our matrix A. So our D and A swap places, so we have -7 and 2, and then we take the opposite signs. So -3 becomes 3, 6 becomes -6. So what you do now is just distribute this 1/4 through your matrix. So A inverse equals, and 1/4 times -7 is -7 fourths. 1/4 times 3 is 3/4. 1/4 times -6 is -6 fourths. And then 1/4 times 2 is 2/4. Now we're almost done. All we have to do is simplify these fractions. We still have -7/4 here. We have 3/4 here. Negative 6/4, we divide a 2 out of both the numerator and denominator, and we get negative 3/2. Do the same thing with 2/4, and we get 1/2. That's a 4. So, the inverse of A, which, let's see if this will be nice and just, well, we can take it right here maybe. Yeah, cool. Here's A. Here's the inverse of A. Now, that's how you do it. But let's just go back and see if, in fact, it is the inverse. Let's just check ourselves. Remember, A times A inverse is going to give you the identity matrix. Well, the identity matrix is just simply a matrix with 1s on the diagonals. So it's going to be something like that. Or actually, it is that. So what we're going to do is just multiply them together and see what happens. We have 2 times negative 7/4, which is going to be negative 14/4, and then that's negative 3, so that's what is that, 9/2 plus 9/2, and then so that's our first element, and we say 2 times 3/4, so that's 6/4, and then minus 3/2. And then we have 6 times 7/4, which is 42/4, and then that's minus 21/2, and then 6 times 3/4, so that's 18/4, and then negative 7 times 1/2, that's plus, okay, so negative 7 times 1 is negative 7, and then that's over halves. Okay, so let's see what happens. Let's clean these fractions up. We've got to, if we're going to add fractions, we're going to have common denominators. So let's write everything in terms of, well, it'd be easiest just to write everything in terms of 4, so all we have to do is double this fraction here. So we got negative 14/4 plus 18/4, and then we've got 6/4 minus 6/4, and then we'll have 42/4 minus 42/4, and then 18/4 minus 14/4. Okay. One last step. We can simplify some of this. Okay, so we have negative 14 plus 18. That's 4/4. 6/4 minus 6/4, say that's 0. 42/4 minus 42/4, that's 0. And 18 minus 14, of course, is 4. So we have 4/4. And as you well know, this is actually a 1. This is actually a 1. So we have 1, 0, 0, 1, which is the identity matrix. So, in fact, that proves that the inverse of 2, negative 3, 6, negative 7 is, in fact, now negative 7/4, 3/4, negative 3/2, and 1/2. So that's finding the inverse of a 2 by 2 matrix.